right, so for example 3. And again, I'm working at posting these videos to my website. So solve x squared minus 4x plus 4 all over x minus 4. And that has to be, we want to find out when it's less than 2. Now, immediately, what we're looking for, because we're doing inequalities, is we're going to do those intervals again. Again, last unit when we had polynomial functions and we were solving those inequalities, we had to do that chart, right? The positive, the negatives, figuring out what was happening in there. And so the first thing you look at is with rational functions, we have a denominator that could possibly be 0. So one of the values that we are going to have to put in our table is x equals 4, because x equals 4 is what we call a critical number. Because something happens there. And in this case, what happens there is there's an asymptote there. There's a vertical asymptote there. So it's a critical number. We got to decide whether it's going to be positive or negative. Something happens at that vertical asymptote on either side, right? So we're not sure if it's both positive on each side or negative on each side. All right, now to solve this, what we need is a 0 on one side of our equation, all right? Because when we do our chart, it's all about positive or negative relative to 0. So what I'm going to do is move that negative or that 2 over to the other side. And so I have x squared minus 4x plus 4 all over x minus 4 minus 2 is less than 0. So there we got our 0 on the one side of our inequality. And then what I'm going to do is get a common denominator. Now to do that, let's see here, I'm going to do what I did at 9 o'clock there, where this is just a 1, so I want an x minus 4 in the bottom. Well, if I do that to the denominator, I don't want to change it, so I'm going to multiply the numerator by x minus 4. All right, so now what they have is a common denominator. So I can write this out. So I have an x minus 4 in the bottom. All right, and on the top, I have an x squared minus 4x plus 4. And then I've got a negative 2 here times the x. So I'm just rainbow ruling. I'm expanding it. So minus 2x plus 8. All right. Now, I simplify the top. All right. So I've got x squared. Let's see. I got to put my x's together. I got a minus 4x and a minus 2x. It's minus 6x. Put my numbers together. I got a positive 12. And that's less than 0. Now, here's the key. When we are looking for values to solve our inequality, we already have one here that's going to be on our chart, and that's x equals 4. The other numbers come from when the numerator is equal to 0. So you're looking for your critical numbers, they're called, or the numbers that we put in our chart, or when your denominator equals 0. So that's when you have vertical asymptotes. Something can happen in there. Or when your numerator equals 0. So that is a point where your graph is either going above or below your x-axis. And so I have to solve my quadratic on the top here, fortunately. Let's see, try to factor it. That's the easiest way, right? X squared, I got 12 over here, x times x. Two numbers that multiply, let's see, give me 12, but flip to negative 6. I don't know, minus 4 and 3. Crisscross, no, that's not going to work. And in fact, I'll save you the time. Nothing's going to work. I got to go to the quadratic formula. And so when I go to the quadratic formula, to get the other numbers I'm going to use in my chart, and again, this is the polynomial that I am going to use for my chart. All right, right there. All right, so again, I've got to use a quadratic formula for the beginning. So I got negative b. Well, b is already negative, so it's going to be 6. Plus or minus the square root of b squared. So that's negative 6 squared, which would be 36. Minus 4ac. Well, a is 1, c is 12. So I got a 1 and a 12 there. All right, divided by 2a. which is 2, because again, a is 1. All right, just doing my quadratic formula. Look at x equals 6 plus or minus, let's see here, 36 minus 4 times 1 is 4 times 12, 4 12s, 48 hours. Divided by 2. All right, and well, look at here, 36 minus 48, that's going to be negative. So actually there is no solutions. Our numerator is never 0. What are you going to do? All right, so now where do I go from there? That's where we start to do those charts again. We only have one number. That's all we have to worry about. So there's a 4, and you're either after 4 or you're before 4. All right, and so now I'm going to use my values here, my finished polynomial or my cleaned up polynomial, to see when it is less than 0. And so I need a number left of 4, right? So an easy one would be 0. So I plug in a 0. I get negative 4 on the bottom, right? So it matters. Here, how do I want to write this? I'll do that down here. So I got a negative on the bottom, right? Put little brackets around it because I put a 0 in there. It's minus 4. A 0 here, that's 0, minus 0, and then up top would be positive. So if I have a positive numerator divided by negative, I'm going to have a negative total number here. All right, now you got to watch because 4 is an asymptote, because I know some of you like the charts. Is it including the 4? No, because the function is undefined at 4 because there's a vertical asymptote there. So what you're looking at when you're solving rational inequalities is not only when it's 0, but when it's undefined. That's the difference between when we were solving polynomial inequalities and rational inequalities. We have to also include when it is undefined. And our function here, or this equation, is undefined when x equals 4. All right, now I look at greater than 4, right? So 5, well, the bottom, 5 minus 4, that's the easy one. It's going to be positive. All right, now let's see here. Plug in a 5 here. So that would be 25. 5, negative 6, that'd be minus 30. Plus 12. Let's see, 25 minus 30. Again, I'm just using a test number of 5 here. 25 minus 30 is minus 5 plus 12. It's going to be positive. And so it's going to be positive. So for our inequality, we're asking, when is this function less than 0? Because that's what we did. We took our original inequality, simplified it down to this. Well, there it is right there. When is it negative? When is it less than 0? The answer is when it is less than, x is less than 4. And that's how we solve that inequality. Open her up to questions. I'll check the chat here. If you use negative 3 and negative 4, it will add up to negative 7, not negative 6. Yeah, I know, it didn't work. All right. Yeah, I'm going to do another example. I'm going to do the next one, which is number 4. I'm going to do them all. All right, except for the first 2. But all right, so we'll do example 4 here. Let's see here. Again, I'm trying to give you all the situations that are possible. So that's one where we only had one number, and that was just because the bottom was undefined. All right, let's check out our next example here. Number 4, where we have x squared plus 2x minus 8. And the denominator here is x minus 2 and greater than 0. So I don't have to move anything around here because it's already done. Now, immediately, see our denominator. It's undefined at that at x equals 2. So one of our numbers in our chart is going to be x equals 2 because there's a vertical asymptote there. I don't know what's going on. All right, before and after it. Now, our top, again, we're going to try to solve. So the easiest to see when it equals 0, the easiest thing is to try to factor it again. Let's see here. So I got an x squared here, minus 8. X squared is always x times x, minus 8. Let's see here. How about a 4 and a negative 2? 4 times x is 4x minus 2x. That does give us a 2x. So I'm going to rewrite my polynomial as x plus 4, x minus 2, and on the bottom, we've got an x minus 2. All right, so again, I'm looking, greater than 0. Don't forget that part. All right, so again, what I'm looking at is, I've already covered the denominator, when it could be equal to 0, looking at critical number there for vertical asymptotes. And then I look for when my numerator could possibly be 0. Well, x equals 2. We already got that covered. But then we also have another one here with our x plus 4. The x value that would make that equal to 0 is x equals negative 4. All right, so here's the polynomial, simplified polynomial that I'm going to use for my chart. All right, so I got 2 and a negative 4. So again, I'm going to do my number line. All right, so we got our negative 4 right here, and we got our 2 right here. So we got a 0, our function equals 0 here, and a vertical asymptote there. All right, so I'm going to test it out to see what we got. So, and again, when I test it out, I get 2 pieces on the top and a piece on the bottom. So if I plug in a number that's left of negative 4, negative 5, for instance, well, the bottom, negative 5 minus 2, that's definitely negative. Negative 5 plus 4, that's negative. And, well, we already looked at these 2 pieces are the same, right? So a negative 5 minus 2, that's negative. Well, what happens? A negative times a negative is a positive, but divided by a negative, it's negative there. All right. Now in between negative 4 and 2. All right, so what's the easiest one? 0, right? 0 here, that's going to be negative, which means this part's going to be negative. Put a 0 here, that's going to be positive. And so a positive times a negative is negative, but divided by a negative, the whole thing will be positive. All right, now x is greater than 2. So obviously I'm going to go with 3, see what happens. All right, and so 3. Well, 3 minus 2 is 1. It's positive, and again, the other piece is the same. 3 plus 4 is also positive. Everything is positive. There we go. All right, so our original inequality is asking when is our function here greater than 0, which means positive. Well, from negative 4, so I'll put f of x is greater than 0 when, number 1, we got between negative 4 and 2 and after 2. So for those of you who think the chart is always positive, negative, positive, negative, positive, negative, or negative, positive, negative, positive, back and forth, sometimes it isn't. We got 2 positives in a row there on the interval. All right, any questions at all? All right. Now, the granddaddy of them all, right? Example 5. All right, so all right, so here we go. All right, so example 5, we got 2x. I need a lot of room here. 2x plus 1. We got 2x minus 3. So there's a rational function. I want to know when that rational function is greater than the other rational function, which is x plus 1 divided by x minus 5. And whoops, yep, that's it there. Okay. All right, so again, because when we do our chart, everything's in reference to 0, I'm going to move one of these rational functions to the other side. All right, so I'm going to move this x plus 1 divided by x minus 5 over with the other one. And so here we go. We have 2x plus 1 all over 2x minus 3. Moving it over changes sign, so subtraction, x plus 1 times x minus 5, and again, greater than 0. So we got 0 on one side. That's what's got to happen. Now, I already messed up a little bit. Not messed up. I just missed some stuff. Again, right off the bat, I got to look at where we have vertical asymptotes. I got one here on this side. X equals 5 is going to be in my chart. I look here. What makes this denominator equal to 0? X equals 3/2. So right away, we have two critical numbers. Those are two numbers going to be in our table. All right, so then what we're going to do is put these two rational equations together and make them one term, and then figure out when the numerator is equal to 0, and that will give us, I don't know, 1, 2, none potential critical numbers. So here we go. Let's see here. So again, I got to get a common denominator, put these two together. So I'm going to have to multiply this bottom here by x minus 5. All right, I got to do the same thing to the top. All right, this one I got to multiply by 2x minus 3. Again, I got to do the same thing to the top. Okay, look out. Here we go. A lot of number crunching going on here. So on the top, we got a common denominator here. We now have it 2x minus 3 times x minus 5. All right, we ain't touching that from here on out. We're just going to figure out the numerator. All right, so we got a 2x plus 1, x minus 5, minus x plus 1, 2x minus 3. Okay, so we got to do some FOIL here and a FOIL here. Okay, so here we go. Again, don't forget my denominator. I see people do that. Then you need it for your table at the end because we need our, whoops, greater than 0. Need our all our pieces to do our table. And so let's see here. 2x times x is 2x squared. All right, then I got 2x times minus 5, which is minus 10x. But then the next ones are going to be a positive 1x. So I'm going to put them together right away. I'm going to do a little quicker math because I know I'm going to probably run out of room here. So that's going to be minus 9x, and the number is 1 minus times minus 5. So we got a 1 minus 5 here. Now, you don't watch here for this minus sign. Minus. I'm going to put everything in brackets because I'm going to have to change the sign of everything. All right, so I got x times 2x is 2x squared. All right, then I got x times negative 3x. So that's going to be negative 3x. But then 1 times 2x is getting 2x's back. So it's going to be minus 1x. Whoops. When I put those terms together. And then 1 times minus 3. Okay. Now, expanding that minus sign throughout. All right, how are we doing for space here? So we'll go 2x squared minus 9x minus 5. All right, minus 2x squared minus 1x plus 3. Greater than 0. And again, can't forget my denominator. Okay, now simplifying the top. Oh, look at this, we got lucky. So because I got a 2x squared and a minus 2x squared. So those terms, they cancel each other out. They're gone. They add and subtract each other out. So that helps. Okay, let's see here. So we got our denominator here, which is the 2x minus 3, x minus 5. Let's see here. So I put my x together. I got a minus 9x plus an x. That's minus 8x. And then we have a minus 5 plus a 3. So that's minus 2. All right. So again, the whole thing of getting our critical numbers, we already took care of the denominators, right? Now it's the numerator. I got something I can work with here. Minus x minus 2. When does that equal 0? Let's see here. Minus x -2, when's it equal to 0? Bring the 2 over the other side. The -2 over the other side becomes positive. Divide both sides by -8. I believe I'm getting -1/4. All right, so there's our 3 numbers that we have to put in our chart. All right, so here we go. And again, we got our simplified polynomial for the chart. All right, so here we go. Got to set up the chart. What's our big number here? 5. 3 halves. Doesn't matter where I put these, as long as I got some space to do my little. And I got a -1/4. Okay. So we got 1, 2, 3, 4 spots that we have to figure out what's going on. All right. So I'm going to go over I'm going to use a different color here because things are a little crowded. You know what? We'll leave it. All right. So I got 2 pieces on the bottom, 1 piece on the top. All right. So 1 piece on the top, 2 on the bottom. I'm going to do that for each spot, interval. All right, I got 1 piece on the top, 2 on the bottom. Okay, here we go. I need a test point. A number left of -1/4. I'm going to go with -1. I put a -1 in the top. -8 times -1 is a +8 minus a 2. That would be positive. 2 times -1 would be -2 minus 3. Well, that's going to be negative. And -1 minus 5. That's also negative. But look at this. We get 2 negatives come together to give you a positive, and we take a positive divided by a positive. That interval, our equation is going to be positive. Okay. What else we got? In between -1/4 and 3 halves. 3 halves is 1.5. It's -1/4. So I'm going to go with 0. Very easy. Top 0. We got a -2. It's going to be negative. Let's see. I put a 0 in here. That's going to be negative. I put a 0 in here. That's going to be negative. And so again, the bottom is going to give us a positive number, but you take a negative divided by a positive. It's going to be negative at that point, our whole function. All right. Next on, number between 3 halves and 5. I'm going to go with 2. All right, so I put a 2 in the top. -8 times 2 is -16 minus 2. That's definitely negative. Put a 2 in this piece. 2 times 2 is 4 minus 3. That'd be positive, actually. And then put a 2 in here. 2 minus 5 would be a -3, so it would be negative. And so on the bottom, positive times a negative is going to be a negative, but if you take a negative and divide by negative, it's going to be positive. All right, well, let's see if the trend continues here. Last one, a number greater than 5. I'm going to go with 6. -8 times 6 is like -48 minus 2. Yeah, that's definitely negative. All right, put a 6 in this part here, the 2x minus 3. So 2 times 6 is 12 minus 3. Wow, that's going to be positive. And then a 6 minus 5. That's going to be positive. And so if I look at a negative divided by a positive number, that's going to be negative. And so our final answer. Therefore, what's going to work is we're looking for greater than 0, right? So we're looking for the positives. So our interval is x is less than -1/4. And between -3 halves and 5. And there's our 2 intervals in which the inequality is true. There we go. Any questions? Hit stop recording here. Are we doing an ISU?